Okay, so we're going to be solving another related rates problem. Water is leaking from the bottom of a canonical cup that is 6 inches across and 8 inches deep. Given that the cup loses 0.9 cubic inches of water per minute, at what rate is the water level changing when the water is 4 inches deep? So like most of these related rate problems, I'd recommend first drawing a picture. Okay, by okay, so by no means does your picture need to be very good. It just kind of gives us a better idea of what's going on. Like like many of the other related rates problems we've been trying, this problem is also going to include similar triangles. So I'll draw out those triangles now. Okay, so we can see that there's a larger triangle and a smaller triangle. Let's label what we know. We know that this left side is 8 inches on the larger triangle, and the top is going to be 3 inches, which is half of that distance across, or half of our diameter. That is, in fact, going to give us the radius of the top of our large cone. Now we know that this height over here is going to be 4 inches on the smaller triangle, and we don't know what the top of that smaller triangle is going to be, so we're going to label it L. We do know that these are similar triangles because they share an angle. They both have a right angle, and that means that their last angle also needs to be shared because all of the angles have to add up to 180 degrees. Since these are similar triangles, we can create a ratio of their side lengths like so. The 3 inches at the top of the larger triangle is in a ratio with the 8 inches on the left side of the larger triangle, and that ratio needs to be similar to the top of our smaller triangle compared to the left side of our smaller triangle. You can probably see here that we just divided by 2 to get from 8 to 4. So we're going to divide by 2 on top to get L equals 1.5. And that would be the radius of our smaller cone that's created by the water. Okay, now let's look at our problem to see what other information we're given. It says that the cup loses 0.9 cubic inches of water per minute. That word per tells me that that's going to be a rate. And the cubic inches tells me that it's a rate with respect to volume, and minutes is time. So this is going to be dV over dt, the change in volume over time, equals 0.9. The question is asking us for the rate that the water level is changing. The water level is represented by this variable h, or the height of the water. And so the rate at which it's changing, rate tells me derivative. I'm going to be trying to find dH over dt. So now I know I need to find an equation that relates V and H because those are the two rates we're given. I'm not sure what it's going to be yet, but I can start by writing the equation for the volume of a cone. The volume of a cone is simply pi r squared, which is going to be this circle, the area of the circle of the cone. Then I'm going to multiply it by h, which is the height of our cone. And that would give us the volume of this cylinder that the cone is enclosed in. And so to find the volume of the cone portion, I need to multiply that by a third. When I take the derivative of both sides, I'm going to get dv over dt equals 1/3 pi, because those are constants, they can come together. And now I need to find the derivative of r squared times h. Since both our radius and our height are changing, they're both counting as variables in this. When we have two variables multiplied to each other, we're going to have to use product rule to solve for this derivative. For product rule, I'm going to define f as r squared and g as h. Therefore, f prime equals 2r dr over dt, and g prime is just going to equal dh over dt. Substituting that in to f prime g plus fg prime, I'm going to get 2r dr over dt times h plus r squared times dh over dt. If you're not sure what I just did there with the product rule, I'd recommend you checking out my video on how to take the derivative using product rule. So now I'm going to substitute that in for the derivative of r squared times h. So this is going to be multiplied by 2r dr over dt times h plus r squared dh over dt. Now it looks like I'm running out of room, so I'm going to find a second page. Okay, so now that I have this derivative, I'm almost to my answer. Unfortunately, I have this dr over dt that I don't have any value for, and I don't really know what to do with it. So I need to relate this dr over dt either to dh over dt or dv over dt. If we think about earlier, we said that for this triangle, we're going to have a ratio of our side lengths. Specifically, my r is always going to be equal to 3/8 of my h. So when my h was 8, my r was 3/8 of it. Or when my h was 4, my r was 1.5. And that ratio is always going to hold true. So taking the derivative of both sides, I'm going to get dr over dt equals 3/8 dh over dt. And now I have a substitution that I can put into our equation up here. So if I plug that in, I'm going to get dv over dt equals 1/3 pi times 2r. Wherever I see a dr over dt, I'm going to plug in 3/8 dh over dt, and then that's going to multiply by height. And then let me get this out of the way. I'm going to add r squared dh over dt. Awesome. Now I have only dh's over dt's and dv's over dt's. I can plug in some values that I know. So the question was specifically asking for when h equals 4. And we solved for r to be 1.5. And that should be all the values I need to plug in. dv over dt equals 1/3 pi. And now I'm going to plug in those values and speed it up so you don't have to sit here. Awesome. Now I can solve for dh over dt by multiplying this by its reciprocal, so multiplying by 24 over 54 pi. And I can plug in dv over dt to be 0.9 times, and then I'm going to multiply by that reciprocal again. And that's going to give me what dh over dt is. And when I plug that in, I get I get dH over dt to equal 0.127, and that's height per time. So in this case, that's going to be inches per second. Nope, per minute. We were using minutes. And that would be the answer to this problem. Okay, so one quick note after the fact. Because the original problem says that we're losing water, our dV over dt should be negative, and then as a result, our dH over dt should also be negative because we're losing that height or decreasing, and so our answer should be negative 0.127, and that is the final answer. Thank you.